So we work for Babcock. If you're not familiar with Babcock, we're mainly known for building big gray things, so warships, submarines. We're the oldest defense contractor in the UK, but we do a lot more than just build heavy machinery. So we have 8 sectors across the business, doing everything from controlling the UK's military satellite network, training Met Police, electronic warfare, and some of the more interesting things with the group that I work with is within is mission systems, so working for security services as well. All right, so I'm going to start off with an overview of AI just to kind of get the point across that what we're seeing out of ChatGPT is only one flavor of AI. There's lots of different algorithms out there that you can choose to develop products with. It's very successful at image and text recognition, so it's got a lot of notoriety. It's offering us the capabilities to do things we haven't done before, but there's a very successful history going back about 75 years of developing products, AI products for defense. Everything from controlling the flight of a missile to radar systems, electronic warfare systems. So there's a lot of different things. So robotics is a very long, storied field. There's lots of stuff in natural language processing. That's kind of my main area of expertise that I spent most of the last 12 years in. It's not just ChatGPT. There's lots of different algorithms out there for doing lots of different things. So there's this 75-year history of doing this, going back to Turing in 1945. Probably can't see much on this, but I'll put this up. This is one of my favorite historians of AI. So if you are curious about the history of AI, Danielle J. Williams, she sells these posters. I've been trying to get one. They're hard to get over here in the UK. But if you're curious about this, or there's another woman named Maggie Bowden. She's the kind of UK's preeminent historian of AI. So either of those are great people to go look at. If you're curious, the history going back to all the different algorithms where we came in the 80s from expert systems where it was all very rule-based, going through the 90s where things became very statistical, up to where we are now, where we have more neural systems, and the future of where we're going, it's going to be something like neural symbolic systems are going to be the things we'll be working on. Yeah, so just a quick run through my career, some highlights. I've been a lot of different places. The first half of my career, I was an academic, and then I worked for venture capital as a research analyst. So I was at University of Sussex. I did my doctorate when I came over here about 19 years ago. I've worked for a lot of commercial companies, most recently at Amazon before I joined Babcock. I was out in the startup world. I got into Amazon because I was part of a startup that got acquired by Amazon. So I'll show you a bit in a minute, but our claim to fame was we built the trust and safety system for Twitch, and then Amazon bought us. So as an academic, I was a neuroscientist initially and did some molecular biology, but I'd always used programming as part of the work that I was doing. So probably the most interesting project was the last one I worked on, was looking at a very simple brain, seeing if we could figure out how to reverse engineer it. So some of this was very wet neuroscience stuff. It was figuring out how to work on a brain outside of the animal, so very Frankensteinian, put it onto a multi-electrode array so we could record lots and lots of signals from that snail brain. But then we produced so much data doing this, we had to use AI to be able to process all of that. So this actually has a lot of overlap with the stuff we're doing in defense now. If you imagine lots of things putting out lots of electrical signals you're interested in, like radio frequency, being able to figure out what those devices are, how they're all talking to each other, so very relevant to some of the stuff for the military, as well as biology. So after I left academia, I got very interested in looking at networks of people as opposed to networks of neurons. So worked for social media companies and digital marketing companies for a while. Brandwatch was one of the big ones I worked for. So we took Eurovision one year and processed all of the data about everything everybody said about Eurovision for an entire day. And then particularly focused on the event itself to see if we could see what everybody was talking about, all the topics. Were they talking about the outfits, the song? And this was very relevant to the people we're working for. So one of the commercial clients we're working for was EA Games, who wanted to know everything everybody said about their games across the entire internet. So being able to show them the capability that we could understand in very great detail what people were talking about, any topic of interest, that brought us a lot of attention for doing this kind of work. I did some work pro bono for Citizens Advice and a very good charity called DataKind. So I would very much encourage any budding data scientists, software engineers, go volunteer for DataKind. You will learn so much on a weekend going out with them. So they provide pro bono services to other charities, data science services. So they'll come in and look at the data an organization might hold and try and help them make sense of it. So this is what we did for Citizens Advice. And so a weekend hackathon turned into a year-long project. So I led this team that we looked at all the data coming out of all of the Citizens Advice offices around the country. And we could tell exactly the effect of, so say, a new piece of legislation having an impact on people, like are they having problems with their landlords? Are they having problems accessing benefits? So we could immediately see those effects as soon as those reports started to come into the offices about what people were talking about. Prior to this, Citizens Advice didn't really have a good way of looking at all of this data. So a lot of language processing AI here, a lot of social network analysis as well. I got very interested in next generation city data platforms. So this was some work I did with the University of Brighton, trying to figure out how to model an entire city and tell the council or other interested parties. So this was focused on Brighton. Everything that was going on in that city. Could you solve traffic problems? Could you solve problems with trying to make decisions about, there's a lot of tourists coming down. Are they tearing up the roads, tearing up the pavements? Do we want to make that investment into tourism? Fixing lots of different problems around the city. So then the last period of my career, I worked for a few different startups. I wound up working for a startup called Spirit AI that was doing trust and safety for games and social media platforms. We wound up with a very good client, Twitch, who's owned by Amazon. We built their trust and safety platform so anytime you chat on Twitch, so where Twitch is there, you would have a streamer talking to you. And Twitch's claim to fame is that you have very low latency, that you can, when you say something in chat, the streamer can see it almost immediately. But it's also very expensive to run that kind of service. But one of the concerns was the toxicity that could possibly come out of stuff in chat. So all of the voice and all of the text that goes through Twitch, we analyzed for any toxicity, misogyny, racism, what have you, and were able to remove that in under a half a second. So you couldn't even notice the difference. So we developed a very, very fast AI text processing system to look for toxicity. So this led me into the work with Babcock. So we took that system a few years ago at the startup and developed a way of looking at lots and lots of data. So military data or intelligence data in the same way we're looking at trust and safety data. And so we wanted to see, could we, say, look at things from Ukraine and see if we could figure out what an adversary was talking about in all their communications. So it turned out to be pretty successful, and that's what led me to Babcock. So the last 5 months since I've been at Babcock, what I've started doing is looking at the MOD's wish list. What do they really want? How do they want to use AI? And so this is from the Defense AI Center. This is MOD telling us what they want. Just so I can read off this, we'll stand back here. So they want to be able to recognize things. They want to be able to comprehend. So it's like communications intelligence, what people are saying. Being able to predict events, what's about to happen on the battlefield. How do you simulate particular scenarios? How do you generate new information? So if you are worried about a particular event happening, can I simulate that event happening? And how do I make better decisions about what's going on with military data? So we're looking at this entire wish list and seeing, can we develop products to satisfy this wish list? So looking out across Babcock, the areas that we're thinking about, language is a big one. So in terms of communications intelligence, conversational systems. So for manufacturing or engineering systems, could we make a system so you could literally talk to an engineering system or a manufacturing system to ask it how it's doing? Is it about to need maintenance? Is it going to need repair? EM spectrum, looking at all the different things that are emitting radio frequencies, looking at all the different communications, not just from a language perspective, but from an electromagnetic perspective. Looking at engineering systems, can we support engineers in actually designing products, predictive maintenance, and doing stuff like fault diagnosis. So lots and lots of different things. So this is kind of the menu of options we're looking at across the entire company. Prior to me joining, there were bits and pieces of AI going on across the company, but we're trying to bring all the threads together into a single team that can support all of these different use cases. Okay, so now talking about, for you guys, training the next generation of software engineers. Software engineering is rapidly changing now in the face of AI. You're getting coding assistants. Right now, they're not that great for actual production code, but what they are really good for at the moment is teaching you the basics. If you want to go learn a programming language, probably the best way to do it now is go talk to ChatGPT or Gemini or one of the other models out there, and they're constantly beating each other in terms of performance for these tasks. So that I would highly suggest that any course you go to learn programming languages, pick a project, go out and actually talk to a language model about that project. Ask it, how would you do this? How would you do that? The best way I found to use generative AI myself is for exploring the possibility space for different things. And that's not just for coding, for creative writing, technical writing, that kind of thing, using it as an assistant. So yeah, as I was saying, they're not great right now for complex, subtle, or novel code or secure code. It tends to produce very buggy code, so you need to do a lot of human review. They will get better pretty quick, probably, but at the moment, not great. And the other thing, coders are worried about being replaced. Good coders, I don't think, will be replaced because this has happened before. People used to code on punch cards. They used to use machine code. We don't do that kind of thing anymore. We keep building these layers of abstraction, and AI is just another layer of abstraction. You kind of move up a layer, and now you're more of a software manager or editor than you might be a low-level coder. I think it's the direction we're heading in. So quick view of what AI product development looks like right now. So you have to go through all these different stages. You need to collect the data. You need to store it. You need to prepare it. You need to pick a model and train that model. Then you need to do quality assurance on that model and security assurance on that model. Then you might want to have multiple models together in what we call a hybrid system. And then you got to figure out how to put that into an app and put it out there in the world. So the point of this slide is there's lots and lots of different roles within AI. Maybe you're all the way back at being a data engineer. You want to figure out how to build the database systems to do this stuff. Maybe you're a data scientist. And you take the first half, basically, of this type of stuff. You pick a model and you figure out how to train it. And that data scientist can be a specialist. I've worked with computational linguists and behavioral scientists who were data scientists of a very specific type. So people are very interested in language, people are very interested in human behavior, and teaching them how to use AI models to research questions in that space. You might want to be an AI systems engineer and figure out how to put together lots and lots of different AI models. And you may want to be an app developer where you use an AI model somebody else has developed to create the next app. So I'll run through this really quickly. Basically, AI-driven product development in the future. So you want to know exactly what your client's requirements are and what the suitability of any AI model is doing therefore. You have a lot of people using ChatGPT, large language models, as kind of a hammer because everything looks like a nail to them at the moment, but that's not always the right thing to do. Sometimes AI isn't even the right answer, so you have to know what algorithm to match to what problem you're trying to solve. There's lots of different ways humans can interact with these systems. We talk about humans in the loop, so that's a human and an AI working together, but other ways you might have a human, what we call on the loop, where they're supervising an AI that's largely operating autonomously. It might be above the loop, where you're just setting rules. You let the system go off on its own. You're setting the rules and the ethics the system can use. Or you might be behind the loop, which is you're only evaluating what the AI system did after it started working, after the fact. So we're going to see a lot less code developed from scratch, probably like basic coding. A lot of that's going to be picked up by AI. You'll have a lot more human review because we're not sure about the quality of the code right now. So people are kind of shifting into that mode, doing a lot of code quality, code security, and model quality testing. Finally, I'll leave you with the scary slide. So command economies, and really we're talking about China here, are moving quicker than Western economies right now in terms of practical applications for AI in defense. So the West is starting to respond to this, but we need to figure out, because a command economy can just come and grab a startup, grab a technology, and demand that it be put into their defense ecosystem. We don't have that same space of possibility. So I'll leave you with, I'm running over time, so I want to give Josh his 5 minutes. So AI is the ultimate first mover advantage. So we really need, particularly for defense, to up our game in terms of what we're doing with AI.